Well, happy Friday to you. I know, of course, it may be Saturday or Sunday when you're watching this video, but happy day to you, whatever day it is. As we review some problems from section this week, we are going to be looking at particularly problems from sections 2.1 and 2.3 so that you are prepared to help tutor those students as they come in with possible questions from those sections. So let's look at the first problem that I sent you through email. Our first problem asks us to find the distance between 5, 0 and -3, 8. So our distance formula is this. Now, for the final exam, students will not have to memorize the distance formula, but it is likely that for the next test, students would need to know that formula. So be sure you tell them to go ahead and learn that formula. Label your points. The first one would be x1, y1, and the second one x2, y2. And then fill in your parentheses. So x2 is -3 and x1 is 5, y2 is 8 and y1 is 0. -3 minus 5 is -8, and 8 minus 0 is 8. -8 squared is 64, and 8 squared is 64. And 64 plus 64 is 128. We always need to simplify the square roots if possible, not type them into the calculator for a decimal answer. So make a factor tree for 128. It's 2 times 64. 64 is 8 times 8. And since I have a pair here, I can pull out an 8 to represent that pair, and the 2 is left underneath that root. And so our distance here is 8 square roots of 2. Now, by the way, most of the time when I'm simplifying roots and I make my factor tree, I do break my number down into prime numbers. So 64 is 8 times 8, 8 is 4 times 2, and 4 is 2 times 2. And I do look for those pairs. And so I have a pair of 2s, a pair of 2s, and a pair of 2s. So I'd have 2 times 2 times 2. And then I have a 2 that's still left underneath that root. And you still get 8 square roots of 2. The only reason I stopped here is because I already saw that I had a pair, and so I didn't have to break those 8s down further. Look at number 2. Number 2 asks us to find our midpoint. Again, on the final exam, the formula for the midpoint will be given, but likely on the next test, students will need to know that formula. So as students come in to ask for help, make sure that you remind them to learn their formulas for distance, for midpoint. Those are probably the 2 formulas that they're going to see in this unit. Label your points, x1, y1, x2, y2, and again, plug in. So x1 is 6, x2 is -3, y1 is 2, and y2 is 10. 6 plus -3 is 3. And 2 plus 10 is 12. Simplify your fraction, and we get 3/2 and 6. Now the next problem works a little bit differently. The next problem gives us the midpoint and an endpoint. And we're asked to find the other endpoint. So the difference between 1 and 2 is this. 2 gives us the two ends, and we're asked to find the middle. But number 3 gives us an endpoint and the middle, and we're asked to find this other endpoint. So that's the difference between those two types of problems. You might want to talk with the instructor that you're working with just to see how they prefer the problem to be worked. I like using a graph to work this problem, but you can also use equations. So I'm going to go ahead and sketch my Cartesian plane. And a lot of times when I'm teaching this in class, I will go ahead and draw the grid lines in very lightly. And the grid lines are going to help us count and move from one point to another. And so we start with the midpoint is -1, 2. So here's our midpoint. The other, our one endpoint, is the point -7, 6. And I'm just going to label that one E for endpoint. Now, I know that if the middle is here and my endpoint is here, my other endpoint is going to be somewhere on this side. And I'm going to count. To get from the endpoint to the midpoint, I go down 1, 2, 3, 4. And I move to the right 1, 2, 3, 4, 5, 6. Then I'm going to follow that same pattern. So I go down 1, 2, 3, 4, and I go to the right 6. 1, 2, 3, 4, 5, 6. And so the coordinates of this point would be 5, -2. Now, another way that you can work this same problem is using equations. I like the graph because it gives students a visual picture of what's happening, but we can also use an equation. So our midpoint was -1, 2, and our endpoint, I'll just call it E, is -7, 6. Our formula for midpoint is this. Now, I don't know what that other endpoint is, so I'm just going to call it xy. In the first fraction in the numerator, I have the x coordinates, so -7 plus x. And in the second fraction, I'll have the y coordinates, 6 plus y. Well, one thing about the midpoint is that if the x-coordinate here is -1, that means that this x also has to equal -1. And so I would write my equation, and I would say -1 equals -7 plus x over 2. Multiply both sides by 2 to get rid of that fraction. And on the left side, we have -2. On the right side, -7 plus x. And then add 7 to both sides. And we get that x is 5. The same type thing happens with my y's. And so since my y-coordinate is 2, this formula for the y also has to equal 2. And so I come down here and I say 2 equals 6 plus y over 2. Multiply both sides by 2 to get rid of that fraction. We get 4 on the left side, and then subtract 6 from both sides to get that y by itself. And we get that y is -2. And so the coordinates of the point then would be 5, -2. That's the same coordinates, those are the same coordinates that we got up here. Again, just ask the instructor that you're working with to be sure that you know which way that they want the problem worked. All right, look at number 4. I may not work all the way through number 4, but I'll work at least one of those parts. In number 4, we're asked to graph. And we're given an equation as well as some points to plug in. I like to show my points on a t-table. And so my x's that I'm plugging in are 3, 4, 7, and 12. And I'm going to start by plugging in 3 for x. Three minus 3 is 0, and the square root of 0 is 0. Then plug in 4 for x. 4 minus 3 is 1, and the square root of 1 is 1. Plug in 7 for x. 7 minus 3 is 4, and the square root of 4 is 2. And then last, plug in 12. And 12 minus 3 is 9, and the square root of 9 is 3. And then you would plot your points and sketch your graph. And so we have the point 3, 0, we have the point 4, 1, we have the point 7, 2, and then 12, 3. When you have the square root makes what I call a ray, so it only has an arrow on one side. Notice that it stops here at the point 3, 0. You would do the same thing from that worksheet for parts B and C. Part B, by the way, with that absolute value, you end up with a V shape for the graph. And part C, with the squared, you end up with a parabola. Number 5 asks us to decide whether or not each relation is a function. And And so part A, we have a V-shaped graph. I use the vertical line test to decide if something is a function. And a vertical line anywhere on this V-shape would only touch that V-shape at one point in the time. And so this one is a function because it passes the vertical line test. In part B, we have this S shape. If I were to put a vertical line on that S shape, it touches the graph at more than one point at a time, and so this one is not a function. Because it does not pass the vertical line test. In part C, we have a list of points. When I have a list of points, I want to make sure that no x is repeated. And so this one is a function because no x value is repeated. In part D, again, we have a list of points. But notice here that -1 is repeated as that x value, and so this one is not a function. Because -1 is repeated as an x value. Part E. I teach my students to think about the basic shapes. With an x squared, we have a parabola, and a parabola does pass the vertical line test, and so this one is a function. And then part F, there are a couple of ways to look at this one. And one rule of thumb is for something to be a function, it cannot have an even power of y. Now, there are exceptions to that rule, so you always need to start looking at your points. So what if I were to plug in 1 for x? Well, 1 squared is 1. Subtract the 1 from both sides. And we get that y squared is 15. Use the square root property, so the squared goes away on the left side. On the right side, don't forget your plus or minus, and square root of 15 doesn't simplify. So notice here there are 2 y's for 1x. And so this one is not a function. Number 6 asks us to give the domain and range for these functions. And these are functions. When I'm thinking about domain with a fraction, remember you cannot have 0 in the bottom of a fraction. And so I set that denominator equal to 0. And so I get that x is 16. Now remember, this is the value that's going to make the bottom 0. So really, x cannot be 16. This is the value that I cannot plug in. Well, if I cannot plug in 16, I can plug in any other number. So I could plug in any number less than 16, and I could plug in any number greater than 16. But since I can't plug in 16, I use parentheses at 16. And so my domain here, the arrow points to the left, that's negative infinity. My shading stops at 16. Join pieces with a union. We pick back up at 16, and the arrow keeps going to the right, is positive infinity. Now for the range, I notice that there is no variable in the numerator. And if there's no variable in the numerator, then y can never be 0. And so I put my 0 on the number line. And again, if y cannot be 0, it can be anything less than 0 or anything greater than 0. And I have my parentheses at my 0. And so my range would be negative infinity to 0, join pieces with a union, and 0 to infinity. So let's look at part B. With a square root and domain, we take whatever's under the root, so here 84 minus 6x, and we set it greater than or equal to 0. Now we use that greater than or equal to 0 because whatever's under a square root has to be positive, and positive numbers are greater than 0. And we have the equal to there because it is possible to take the square root of 0. Solve your inequality, so subtract 84 from both sides. Divide both sides by negative 6. And remember, when you divide by a negative, you've got to swap that inequality sign. And 84 divided by 6 would be 14. Put your 14 on your number line. We have a less than, so we shade to the left. And we have a bracket because of the equal to. And so our domain, the arrow points to the left, is negative infinity to 14 with a bracket. Now, when I start thinking about my range, I look at a couple of things. So let me come back up to the problem. Notice here that there's no number written outside that square root at the end of it. You're not adding or subtracting any number from the root. And so what that tells me is that my y value as my range has some relationship with 0. Now I need to figure out if that's going to be a greater than or a less than. Notice that in front of this root is understood to be a positive 1 in front of that root. And since that root is positive, that means we're going to have a greater than or equal to 0. Most of the square root problems that you're going to see are going to have a range of y greater than or equal to 0. I won't say all of them, but most of them will. Put your 0 on the number line, shade to the right because of the greater than, and you get a bracket. And so our range here is from 0 to infinity. Now, by the way, if, let's just say we had had a negative square root of x, then when I'm looking at that range, because it's a negative in front of that square root, I would have a less than or equal to 0. So that's where I'm talking about that positive or that negative. And then last, number 7, we have h of x is given to us, our function. And we're asked to find h of x minus 2. So what that tells me to do is everywhere that there's an x, I'm going to plug a x minus 2 in place of that x. Always square before you distribute. So that means I would multiply x minus 2 times x minus 2. Use FOIL to multiply. So the first term is x squared. The outer is minus 2x. The inner is minus 2x. And the last is a plus 4. And bring down the rest of the expression. And now I'm ready to distribute. So distribute that 2. Gives us 2x squared minus 4x and plus 8. Distribute this negative 4. Gives us negative 4x plus 8. And bring down the plus 8 at the end. Put your like terms together. We've got 2x squared. We'd have negative 12x and plus 24. Well, I hope this helps as you prepare to tutor in the upcoming week. If you have questions, let me know. Otherwise, have a great day.